Namaste and welcome all to the new programming concept which we are going to start as programming Puran with Python. This will be a way of understanding basically a programming from the simple conceptual way. So what we are going to deal with all in this session one by one is how to write the program in a simple way. What is the logic behind that and how to develop that. So that is the concept we have made clear here. So any person starting from any background of any age, any level can easily write the programs specifically using Python. So Python is the base we are going to use for writing the programming concept, and here we are going to develop the logical building so that you can easily write the any kind of program one by one. In this session we are going to conduct many small cases programs, then we will develop to some higher level and the higher level. So step by step, if you follow this whole session, this whole playlist, you will find out that there is very easy way to understand the program and write it and run it. So while starting this session with different examples, let's have an introduction what we have in programming Puran. So let's go to the next slide. So let's have the introduction to programming. Basically, when you introduction to programming, any program which comes into your hand to solve it, we have to go in deep to understand what is the concept behind that, and then only you will be able to write it. So to understand that, some of the points I have just collected. The first one is problem solving aspect. It is the problem solving aspect you have to develop first so that you can easily go ahead to write different complicated complex programs also. So in this we have the problem definition phase. Basically here we talk about what is the problem in hand. Is the problem of say simple exchange of two variables? Is the problem of sorting? Is the problem of sorting with multiple ways like the bubble sort? Maybe is the problem of other related stuff. So the problem definition should be clear at the first step because that is the main thing you should understand. Once your problem definition phase is correct, you get to start with the problem. Again, don't jump to say that the problem is too complicated. How I can divide it? How I can go ahead it? Just start the problem to solve it. And how to start it? You use the specific examples, and that is important. So it is not a thing that it is a you just start writing the code and you get it. No, you think of some examples and then you solve, like a simple sort example. You have to write the bubble sort. So bubble sort, yes, we know the concept behind that, but you cannot write directly code in that. Say some string is there or some array is there with some elements in that. We have some three elements, only four elements. Try to do on manually how the bubble sort will work for this. Once we get the idea how that bubble sort works for that, then only we can jump into solve the problem from the coding perspective. So the use of specific example is very much important. Second thing, when you go for problem solving, you find out the similarities among the problems, and that happens that as we grow on knowing different problems, as we solve it, we come to know yes, there are some problems which I can solve or which I have already solved, which is very much similar here. I can use some of the things in that there. So if I can use some of them which was already solved, it will be better to go ahead with that. So that is also one of the steps you have to think of. What are the other problems which you have already solved? Working backwards from the solution, and that is also a very good method to think to write a code in a simple way. Rather than starting position, we can go reverse. So like example of swapping a number, you may say the numbers are already swapped. Now how the reverse process can work? Like if I am writing a data structure, say list or a tree, or if I am writing a sorting, let's have a sorted array, that is the final output, and let's go back to check what things may have happened. So looking backwards from the solution to the initial point also gives a very good idea how to write a program. There are many strategies available for problem solving. We may not go in detail of all of them, but still I have mentioned some like a divide and conquer, dynamic programming. These are some of the problem solving strategies available comes under the algorithms. So divide and conquer, as the name suggests, it is an example of like a quick sort, where instead of sorting whole array, we divide the array into two parts. Then we divide the two arrays again into two parts, and so on. So we sort the smallest two elements, then jump on to solve four elements, then six elements, and then we combine the complete array. So that is a divide and conquer rule. Whereas dynamic programming, a same big problem may be solved with a small problem which I can solve, and the same thing I can have differently on different aspects, and that will give us an idea that how I can solve the multiple or a big problem, and that is the dynamic programming. Some of the part will be reused again and again, and that is dynamic programming. So all these programming solving aspect you can think of to solve beforehand. And do remember, as in the example I have shown, the crow was able to drink the water by putting small stones in that. So it was not a very easy task, or it was a difficult for the crow, but he has done that. So that is the thing you should remember. Even if the problem statement is very big or it looks like difficult, there are the solutions always. Okay. The next aspect which comes into the picture is the top down design. So when you talk about the top down design, first you break the problem in sub problems. So there is the first thing, you have to break it so that you can understand what are the different parts we have to do, and then we have to combine that to get the actual result. Once we do that, we choose the suitable data structure, because there are many data structure available, and we are also going to deal with many data structures, or we will try to create them also. Okay. So there is array, there is list, set, queue, stack, tree, graph. So many data structures are available. Which data structure will be good for my analysis? Is it a tree? Is it a graph? If I want to do with some say traveling salesperson problem, yes, the graph is the very good. If I want to do with the elements membership problem, yes, set is the good thing. So there are different data structures. You decide what should be the case, or as we can say in our this session, we will decide what will be the case, and then we will try to solve it. Then there is maybe the need, and most of the time it will be a construction of loop. So there may be a single loop, two double nested loop, or maybe multiple loops separately. So every time what kind of loops you have to create, and when you create the loops, how they will execute, how they will terminate, how they will initialize, these are the main points you always think of. Have some small values, try to run that, make sure it is working for all the scenarios, and then you can say yes, the loops which I am going to implement for whatever my program is correct. Establishing the initial condition of loop, as I said, when you construct a loop, you make sure what should be initialized. Is it is a simple while I is greater than 10, I should be initialized with some value. Okay, it is 9, 10, or 11. Finding the iterative construct. When you write the while loop, when you write the for loop, how iteratively I can go one by one step ahead. And termination of loop, and that is important, because if I don't terminate, I may have an infinite loop. That is again a problem, as we everyone knows that infinite loop will create the problem. So all these things you have to decide when you decide for the top-down design for the problem in hand, because that problem has to be solved in that way only. Otherwise, it will create lot of problem. So top-down design is a second part when you have any programming problem you have to solve. Okay. So the next thing comes into the picture is how to implement that implementation of algorithm. So you can use of procedures to emphasize the modularity. Instead of writing a single line code which may be consist of say 100 lines, 200 lines, you try to divide it. You make a small module. So modularity of algorithm is also important. Let's in your program one case you have to swap two numbers. They have a procedure for that where you call the swap. You need a sorted version. Let's have a sort as a procedure or a function. So as modularity you increase, it is easily to read the code. Also, it is easy to implement. Second thing, choice of variable names, because when in industry you work, you cannot have some variable names as A B C D E F G H or I J K L M N, because that will not signify what that is used for. So in general, what you can do, you can say that if one variable I am going to use as an integer, you say A underscore integer. That will directly give an idea that is A and that is integer. Again, A will not give a good idea, so it may be a, say that integer is employee number, so you say employee number underscore integer. So that variable name clearly while reading itself gives the idea, okay, this variable is employee number and it is of integer type. So that is a good variable names construct you always use. Don't use the simple variables. And in Python, since it is a dynamically typed, if you use a simple variable again and again, there may be a problem when automatically it changes its data type. So that thing also you keep in mind. Documentation of programs, that step is also important. Whenever you write, you have to put a documentation properly, because everyone who reads your program, you have to know that after reading that program comments or the documentation string, it is easy to understand which thing is doing what part. Okay, what we are focusing is not just writing a simple algorithm, but focusing more on the bigger side, that when you go into the industry, there should be a good versions of code available for you. Once you write the program, you have to start with debugging the program, and that is the important step, because once you write and it runs for one value, that is fine, but for some other different aspect it may not run, and all kind of aspect you should think to write the program. So once you debug the program, gets the confirmation, you have the program testing. Maybe it is a 5 line of code or maybe it is a 50 line of code. You must have different input to apply and to get the idea how I can test it. Maybe I say a value with 0, if I say a value with 1 2 3 4, if I have very high value, the program should execute properly. It may give error saying you have not given the correct input, or it may run properly, but there should not be the case it crashes. So the program should run for all kinds of inputs. So that is again a one of the thing you should remember to work on. So that is also important. So all these aspects you should remember from the implementation point of view. So that is also important. The fourth and the last thing which comes when you write the algorithm is its efficiency. Is the efficiency is good, or it runs for hours and then give a very small output? So the redundant computation you should first remove. There should not be a redundant computation which is not required, or it is done without any context with what the output is required. So redundant computation has to be removed. Inefficiency due to the late termination. What that means? We get the result in between because of the some condition, but still because we have written a code of 50 lines, we have to run up to the 50 lines. So there should not be the case. If we get the result at one point, there should not be a late termination. We should terminate immediately our program, because we have detected or we have find out what the result should be. Early detection of desired output condition, which is in same way of inefficiency of late termination. So if we detect in the code at any point, yes, that is the desired output, we should end our program rather going one by one. The next thing is computational complexity. So you should be understanding what is the complexity of the computational. That is the complexity which is measured in order of n square. That how many times the loop is executing. Is it an exponential? It is an linear or some other. So that complexity of the program is also important to understand. And along with the worst and average case behavior. So worst and average case behavior generally talks about what is the output when I give a very good input, and what is the output when I give a difficult input. So rather than saying what is the output, we may say that how time it will take to compute that thing to get the desired result. So when the input are good, how much time it will take. When the input are complicated, how much time it takes. So most of the time, the worst and average case should match very near. Okay, they should not be far end from one n to another n cube. Then the program will not be of use. So looking at this, when you solve any program in the programming language, you should think of this four step in mind. And along with the efficiency, you should have the top-down design. you should know what is the problem statement to be solved, and accordingly you have to proceed with. So all these things we are going to understand step by step once we are going to solve different problems in our series. So for this purpose, you do read the next program which we have done with this, which was a exchange of two variables. So do follow that, and also subscribe to our YouTube link. So every time you will have new problem statement with a very basic understanding of how to write it and how to execute it. So thanks for watching this, the Programming Puran with Python. Namaste.